is Dr. SHARMILA Kumari. I am working as an associate professor in PSN College of Engineering and Technology, Tirunelveli. Now we discuss about the topic is electrochemistry. Then the concept of electrochemistry. What is the concept of electrochemistry? Electrochemistry is a study of chemical applications. Some of the chemical applications are related to electrochemistry topic. The electrochemistry deals with the interaction between electrical energy and chemical energy. These interactions have two types. There are two types of interactions are here. Conversions of electrical energy into chemical energy, conversion of chemical energy into electrical energy. Then next one is electrical conductors. What's the meaning of electrical conductors? The substance which allows electric current through it. For example of electrical conductors, metals, graphite, fused salt. Fused salt means the liquid state of salt. Aqueous solution of acid, bases and salt. Then the types of conductors. There are two types of conductors, electronic conductors and electrolytic conductors. And then non-conductors are insulators. What's the meaning of insulators? Means the substance which does not allow electric current through it. Then the example of insulators, rubber, paper, dry wood, etc. Then next topic is metallic conductors. What's the meaning of metallic conductor? Is metallic conductors conduct electricity due to the movement of electrons from one end to another end. In a solid, the electrical conduction involves the free movements of electrons in the metallic lattice without any movement of lattice atom. This there of conductions is called metallic conductions. Lattice atom means the arrangement of the crystal structure. Then metallic conductors, the electricity is carried out by the electrons, the atomic nuclei remaining stationary. Then these conductors are further subclassified into three types. The first one is good conductors, second one semiconductor, third one non-conductor or insulator. Then what is the meaning of good conductors? That is a substance which conduct electricity fully and freely. Say the example of good conductors means metals like copper, aluminium and iron. See the diagram. First one is copper, second aluminium, another one is iron. Then semiconductors. It's a substance which partially conduct electricity. The example of silicon and germanium. Then electrolytic conductors. The substance, their fused form or in the aqueous form allows the passage of current undergoing in stimultaneous chemical transformations are called electrolyte, and the conductions as the electrolytic conductance. The reciprocal of resistance is called as a conductance. The formula is C is equal to 1 by R, and then unit of electrolytic conductors means mho. Resistance is denoted, is represented as R. Of a conductor is directly proportional to its length. Length is denoted L, inversely proportional to the area of cross section A. The formula is R directly proportional to L by A. Then what are the difference between metallic and electrolytic conductors? Then first one is metallic conductors. The first point is conductance is due to the flow of electron. Then electrolytic conductors means the conductance is due to the movements of ions in a solution. Second one, it does not result any chemical change. The metallic conductor does not result any chemical change, but the electrolytic conductors, the chemical reaction takes place at the electrodes. Then third point, metallic conductors decrease with increase in temperature. Electrolytic conductors increase with increase in temperature. The fourth one, it does not involve any transfer of matter. Then electrolytic conductors involves transfer of matter. Then electromotive force. It is short form of electromotive force is EMF. The electromotive force is the difference of potential which causes the current to flow from an electrode at high potential to the one of lower potential. The formula is E cell is equal to E right minus E left. E cell, EMF of the cell. E right, the reduction potential of right hand side electrode. Left means the reduction potential of left hand side electrode. Then what are the applications of EMF measurements? The first one, potentiometric titration can be carried out. The potentiometric titration can be carried out the finding of EMF values. Then transport number of ions can be determined. Then third one, pH can be measured. pH is the potential of hydrogen can be measured. Then fourth one, hydrolysis constant can be determined. The fifth one, solubility of sparingly soluble salt can be found. Then next one is galvanic cell. It is a cell in which chemical energy is converted into electrical energy. This cell consists of two half cells. First one, anodic half cell. Second one, cathodic half cell. The anodic half cell oxidation takes place. At the cathodic half cell is reduction take place. The cathode electrode is copper and the anode is zinc. This oxidation reaction is occurred in liberation of electrons. Zn 2 plus 2 electrons. Then cathodic reactions means the reduction means acceptance of electrons. Cu2 plus 2 electron gives a copper. Then batteries. There are electrochemical cells connected in this series is called batteries. Batteries are storehouses of electricity. They are used as a source of direct and electric current at constant voltage. They are classified into two types. First one, primary cell. Second one, secondary cell. This one is primary cell and next one is a secondary cell. Primary batteries. These are non-rechargeable or for single use or discarded after use. Then secondary batteries is a voltaic cell whose electrochemical reaction can be reversed by a current of electrons running through the battery after the discharge of an electrical current. And that is secondary battery is restored to nearly the same voltage after the power discharge. Primary battery is once used battery, secondary battery is rechargeable battery. Then a difference between primary and secondary batteries. The first one, primary cell. These are non-rechargeable and mean for a single use and to be discarded after use. Then secondary cell means these are rechargeable and mean for multi-site use. Then primary cells, the cell reaction is not reversible. Secondary cells, the cell reaction can be reversed. Primary cell cannot be rechargeable, that is rechargeable. Primary cell is less expensive, secondary cell is expensive. Primary cell can be used as long as the material are active in their combustions. Then it can be used again and again by recharging the cell. The example of primary cell is Lagrange cell or lithium cells. The secondary cells example lead acid cell and nickel cadmium cell. This is the example of primary cell, that is a Lagrange cell. In this cell the reactions are irreversible. It is also known as dry cell. It is once used battery. So we are call it as non-rechargeable battery. That is anode is zinc inner case, cathode graphite rod. Then paste of the electrolyte is magnesium oxide and ammonium chloride and carbon. Then anode is a zinc container, cathode is carbon rod. Then anode reaction is it is oxidation reaction, that the liberation of electron, zinc Zn2 plus 2 electrons. Now the cathode reaction is acceptance of electrons, NH4 plus 2 MnO2 plus 2 electrons gives MnO3 plus 2 NH3 plus H2O. That is overall cell reaction is 2 MnO2 plus 2 NH4Cl plus zinc gives ZnNH3 twice Cl2 plus Mn2O3 plus H2O. Then this is an example of lead storage battery, that is a rechargeable battery. Then anode is lead grid filled with spongely lead. Cathode means lead grid filled with spongely PbO2. Then we are using as the electrolyte is sulfuric acid. Then anode reaction Pb plus HSO4 minus gives PbSO4 plus H plus 2 electrons. Then cathode reaction means there is a reduction reaction, that is acceptance of electrons. PbO2 plus HSO4 minus 3H plus 2 electrons gives PbSO4 plus 2H2O. Then the cell reaction is Pb plus PbO2 plus 2H plus 2HSO4 minus 2PbSO4 plus 2H2O. Then the overall cell reaction is Pb plus PbO2 plus 2H2SO4 plus 2 PbSO4 plus 2 H2O. Then lead acid recharging battery. Then a low self discharge, that is 40% in 1 year, 3 months of nickel cadmium. Here is no memory, cannot be stored when discharged, limited number of full discharges, danger for overheating during charges. Then application, it is used as a automobile and construction equipment, standby backup system for engine batteries. Then advantages, low cost, it is long life cycle, ability to withstand mistreatment, perform well its high and low temperature. Then next one battery is lithium ion battery. It is a secondary battery, it is rechargeable battery. Lithium ion batteries are secondary batteries. The battery consists of an anode of lithium dissolved as ion into a carbon. The cathode material is made up from lithium liberating compounds, typically the 3 electroactive oxide materials. Then lithium cobalt oxide, lithium manganese oxide and lithium nickel oxide. It's the principles of lithium battery. During the charging and discharging process, lithium ions are instead or extended from interstitial space between atomic layers with the active material of the battery. Similarly, the lithium ion is transferred between anode and cathode through lithium electrolyte. Since neither the anode nor the cathode materials essentially change, the operating is safer than that of a lithium metal battery. This is the diagram of lithium ion battery. Like here the charging L plus and discharging Li plus, then positive and negative charges are here. Then advantages, they have high energy density than other rechargeable batteries. Compared to other rechargeable battery, it is high efficiency, high energy density batteries, lithium ion battery. They are less weight, so we can easily transport this battery. They produced high voltage out about 4 volt as compared with other batteries. Then they have improved safety, that is more resistant to over voltage. No liquid electrolyte means they are immersed from leakage. Fast charging and discharging rate. Then disadvantages of lithium ion battery, they are expensive, they are not available in standard cell types. Then applications of lithium ion batteries. Then lithium ion batteries are used in cameras and then calculators. Then they are used in the meter and other imperial device. They are used in telecommunication equipments and instruments, portable radios and TVs and burgers. They are used in operate laptop computers and mobile phone and aerospace applications. This is flow battery. That is a fuel cell. This is an example of flow batteries. It is reactant product and electrolyte are continuously passed through the cell, that is fuel cell. Hydrogen oxygen fuel cell. Here is hydrogen is passed through the anode compartment, oxygen is passed through the cathode compartment. Here is 2 porous electrodes, porous carbon electrode containing nickel. Then cathode is porous carbon electrode containing nickel and nickel oxide. Then molten Na2CO3 is we are used as a electrolyte. Then fuel cells. In the cell, they convert energy of combustion of fuels like hydrogen, methane to electrical energy. Fuels are usually gas or liquid with oxygen as an oxidizer. Different fuels are the direct conversion of chemical energy into electrical energy has 100%. Then the cell representation is followed: fuel, then electrode, then electrolyte, then again electrode, that is oxygen. These are the cell representation rules. Then types of fuels: hydrogen oxygen fuel cell, second one methanol oxygen fuel cell. See the diagram, the hydrogen is passed through the anode compartment where it is oxidized, then oxygen is passed through the cathode compartment where it is reduced. Then anode compartments is occurring oxidation reaction, that is liberation of electrons. Then cathode is acceptance of electron. Then finally it is less harmful fuel cell. The limitations of fuel cell: large weight and volume of hydrogen gas fuel storage system, high cost of hydrogen gas, technical advantage should be bring the cost down, lack of infrastructure for distributions and marketing of hydrogen gas. Then most basic fuel cells suffer from carbon dioxide leakages and should be prevented from entering the cell and reacting with the electrolyte. Then hydrogen, oxygen or alkaline fuel cell. In this fuel cell, electrolysis 25 to 30% occurs potassium hydroxide. We are using as the electrolyte is KOH, that is potassium hydroxide. This cell make use of high purity of hydrogen as fuel, then oxygen as oxidation. See the diagram, hydrogen is a fuel, oxygen is a oxidant. We can use as the liquid electrolyte, that is aqueous KOH. The reaction between hydrogen peroxide takes place to produce water and excess electron produce the electric current. See the diagram, is anode is passed through the hydrogen, then cathode is passed through the oxygen, that is oxidation. Here the electrolyte is KOH. Then see the reactions at anode reactions. Hydrogen is combined with hydroxide ion to give 4 molecules of water plus liberation of electrons. Then cathode reaction, the oxygen is acceptance of electrons to give 4 hydroxide ion. The net cell reaction is hydrogen plus oxygen gives water. See the first we can write hydrogen, then oxygen, then 4 OH and 4 OH, anode and cathode they cancel. Anode is 4 water molecule is there, then here is cathode is 2 water molecules, so cancel the 2 water molecules. Then 4 electron and 4 electrons are cancelled. Finally the net cell reaction is hydrogen plus oxygen gives water. The product discharges water, standard EMF is 1.23 voltage. See the diagram, the reactions are there. Hydrogen plus 4H plus 4 electron, that is oxidation reaction. Then cathode reaction, oxygen plus 4H plus 4 electron gives 2H2O. Then applications, these are used as auxiliary energy source in space vehicles and submarines and military vehicles. This is the example, this is the applications. The product in this cell is water. It is used in the valuable freshwater source for astronauts. Then methanol oxygen fuel cell. This is another one example of fuel cell. Fuel cell example is hydrogen oxygen fuel cell and methanol oxygen fuel cell. Here the carbon dioxide and methanol is passed through the anode. Then here cathode reaction is passed through the air oxygen. Then liberation of water. The methanol is passed through the anode reaction. It is liberation of carbon dioxide. Cathode reaction means oxygen is passed through the cathode. The water molecule is liberated. In the cells, CH3OH is used as a fuel, that is methanol, and oxygen as a oxidant to generate electric current. This cell has 2 electrodes. The porous nickel electrode coated with PT and PD catalyst acts as anode and coated with silver catalyst acts as the cathode. The electrolytes potassium hydroxide taken in between 2 electrolytes. Then the reactions of anode and cathode. At anode, methanol plus 6OH gives liberation of carbon dioxide and liberation of electrons. Then cathode reaction, that is acceptance of electrons. This oxygen accept electrons and water to give 6OH minus. Net reaction CH3OH plus 3,2O2 gives CO2 plus 2H2O. Then what are the advantages of methanol oxygen fuel cell? First one is these cells are reasonably stable at all environmental conditions, easy to transport. Then third one, do not require complex steam reforming operations. The fourth one is methanol poses less risk to aquatic plants, animals, human beings then gasoline. Then advantages of fuel cells. This is the common advantages of fuel cell. The reactants, product and environment friendly, high efficient of energy conversion from chemical energy to electrical energy. The fuels and electrolyte materials are available in plenty and inescapable, unlike fossil fuels. Fuel cells are operable to 200 degrees centrifuge and so find applications is high temperature system. Fuel energy is economical and safe. Fuel cells are compact and transportable. These are the advantages of fuel cells. Two types of fuel cells are here. First one, hydrogen oxygen fuel cell. Another one is methanol oxygen fuel cell. Once always the topic is batteries. The batteries is the electrochemical cells are connected in the series. The batteries, there are two types. The first one, primary battery, and one secondary battery. Primary battery means it is non-rechargeable battery. Secondary battery is a rechargeable battery. These are the difference between primary cells and secondary cells. Primary battery examples of regular cell, that is dry cell. Then lead storage battery and lead acid recharging batteries are secondary battery examples. Lithium ion battery also secondary battery examples. This is the principle. This is the diagram of lithium ion battery. Then flow battery. Flow battery example, hydrogen oxygen fuel cell. This is the flow battery. The fuel cell means reactant, product, electrolyte are continuously passed through the cell. This is the limitations of fuel cell. Then hydrogen oxygen fuel cell is the example of flow battery. Then methanol oxygen fuel cell is the example of flow battery. Then advantages of fuel cell is common. Thank you.